Now that we've oriented ourselves on what scientific notation is and how to convert to it and convert from it, let's talk a little bit about operations with scientific notation, in particular multiplication and division. In short, you're going to want to utilize your exponent rules to deal with the tens to an exponent. You're going to want to normally multiply or divide the actual decimals. For the purposes of making this video not too long, I'm going to do most of that decimal multiplication actually on a calculator to the side. But if you want to do it by hand, I encourage you to check out my decimal arithmetic video. And then if at the end it's not in standard scientific notation, then you're going to want to convert it to scientific notation. So let's take a look at an example of this. So if I have 4.7 times 10 to the negative ninth and 1.2 times 10 to the fourth, what I'm going to want to do there is for the 10 to the ninth times 10 to the fourth, remember that would be essentially 10 to the fourth divided by 10 to the ninth, since 10 to the negative ninth means that he goes in the denominator. I'm going to wind up with 10 to the negative fifth, because 4 minus 9 gives us negative 5. Or you can also think that denominator is going to win out, so to speak. And as for the coefficients, 4.7 times 1.2, I'll do this one by hand to the side here, but then from here on out I'm probably going to use a calculator. 2 times 7 gets us 4, carry the 1. 2 times 4 gets us 8, plus 1 is 9. 1 times 7 is going to get us 7. 1 times 4 gets us 4. Add straight down, we get 4. 9 plus 7 is going to get us 16. 1 plus 4 is going to get us 5. And then we'll need to move over 2 decimal places at the end, 1, 2, to get us 5.64 times 10 to the negative fifth. And that already is in scientific notation, so we're good to go. Similarly, for the next one, we have 10 to the negative second times 10 to the negative fifth. That's going to wind up at 10 to the negative seventh, since negative 2 plus negative 5 is negative 7. Or you can think I have 5 tenths in the denominator times 2 more tenths in the denominator. Going to wind up with 10 to the negative seventh. And then I'm a little bit lazy today, so I'm going to do 3 times 1.266 off to the side here, and that is going to give us 3.798, and that again actually already is in scientific notation, so we are actually good to go. Had it not been, we would have done a little bit more converting. Now we want to keep going, so for these next two I'm going to encourage you to go ahead and try that yourself, and then we'll compare together. So if I have 10 to the positive second times 10 to the positive 11th, that's going to wind up with 10 to the 13th, since I have 11 tens times 2 more tens. And then again, this is another example of a decimal that, just for the sake of time, I'm going to go ahead and write in a calculator off to the side here, which looks like it's going to get us 11.231. Yeah, I'm just actually, that one's going to round to, I'm not going to round, so let's write precisely. So I'm going to need more room here. 10.23198 times 10 to the 13th. Now, this is an example where he is not yet in scientific notation. So we've got to make him look like scientific notation. In particular, we want to move this decimal one more to the left. And we might want to think through how our decimal conversion works. So if I'm moving our decimal place to the left, I end up multiplying by more tens, because in order to move them to the left, I'm wanting to make them into a bigger place value. So here, and it might actually be best to kind of picture this step by step. To move it one more to the left, I really want to do 1.1231968 times an additional 10 to the first to do just that one move to the left. And then I still have this times 10 to the 13th, which will combine 10 to the first times 10 to the 13th is going to make times 10 to the 14th, and I'll still have that 1.1231968. So it might actually be simplest to sort of just think through step by step, hey, for this initial conversion of that coefficient to a number between 1 and 10, what do I have to do? And then toss that on to that initial 10 to whatever exponent you already had just from your exponent rules. And this next one's going to work a similar way. I can already kind of tell that it's going to be a number that's not between 1 and 10, because if I were to round those two numbers as 8 times 10, that's going to give me something in the ballpark of 80. I already know that leading coefficient's not going to be right from the get-go this time. But let's back up a little bit. So 10 to the 11th times 10 to the negative 5th. That's 11 tens on the numerator and 5 tens in the denominator. Is going to give us 10 to the 6th. 11 plus negative 5 gives us 6. For that leading coefficient, I'm going to do that off to the side, and I'm going to expect a number somewhere in the ballpark of 80-ish. I just haven't confirmed exactly what it is yet. It looks like it's 77.9. I'm just going to write down the whole thing. 77.91758804. And again, I've still got to convert this to scientific notation. In particular, I need to move this one more to the left. So that's going to be 7.7917588804. And this was a times in there. So times a 10 to the 1st for that moving it one more to the left, times an additional 10 to the 6th that's already there, for a total of 7.7917588804 times 10 to the 7th. So really, as you're moving decimal places to the left and the right, you're moving its place value, because we're in a base 10 system. So every time you multiply by 10, you're going to be moving that decimal place to the left. Every time we're dividing by 10, we're moving that decimal place to the right in terms of that conversion, effectively. So the division is going to work very, very similarly. So again, you're just going to kind of deal with your coefficients in one place, deal with your tens to an exponent in another place, and then condense your final answer. And in particular, I might actually find it helpful to go ahead and get rid of these negatives when I'm doing this conversion. So we're going to have 2.588 times 10 to the positive 9th over 1.5 times 10 to the positive 11th if we realize how negative exponents work. So that's going to be 2.588 over 1.5 times 10 to the negative 2nd, because 9 minus 11 is negative 2, aka we're going to end up with 2 tens in that denominator. And then I need to convert this leading coefficient as well. Now here with the division, it's probably more likely that that leading coefficient might end up working out okay, but it won't always work out okay. In particular, if that leading coefficient on the numerator is bigger than the denominator, you're going to have to do some additional conversion to that final scientific notation. So here it looks like we get 1.72533, and that 3 is actually repeating technically, times 10 to the negative 2nd. Next one, same idea. So I'm going to encourage you to go ahead and pause your video and try and convert this yourself. And then if you are feeling up to it, I would also convert this one on the bottom as well. So for this next one, again, for these tens, I'm going to go ahead and use my exponent rule. So I have 9.768428 divided by 3.54 times 10 to the 5th over 10 to the negative 3rd. It's going to become 10 to the 5th times 10 to the positive 3rd, all in that numerator. So that's going to wind up with times 10 to the positive 8th, effectively. 5 minus negative 3 does give me positive 8. And then I'm going to do that division of the coefficients off here to the side. So we have 9.768428 divided by 3.54. And that's going to give us 2.7594. And then I'm just going to choose to round to that decimal place, but this is technically rounded, just to let you know. So pay attention to how many decimal places they really want you to give there. For this next one, you're allowed to sort of move in whatever order you want, but again, I'm going to kind of condense my coefficients together and then deal with my tens separately. So in particular with my coefficients, I've got 7.988 times 9.7, I'm actually going to do it times with an x this time because there's so many decimals floating around, 433 over 2.3. And then in terms of the tens, I've got times 10 to the negative 5th times 10 to the 11th over 10 to the third. And I'm going to just deal with them separately. So I'm actually going to convert the 10s so that I've only got positive exponents. So we've got 10 to the 11th over 10 to the 5th times 10 to the third, which becomes 10 to the 11th divided by 10 to the 8th, which would end up simplifying to just plain old 10 to the third, right? Because we've got 10 to the 11th. We've got 11 tens divided by 8 tens. 11 minus 8 gets us 3. It's going to be 10 to the third in that numerator. Now I'm going to deal with my coefficients here off to the side, so I'm also going to do that on a calculator separately, just because we would be here for a while if you saw me do that entirely by hand. Not to say I can't, but just, and also as like a quick sanity check, I'm going to expect something in the ballpark of, 40-ish, because I've got 8-ish times 10-ish divided by 2-ish, and I do get something in the ballpark of 40-ish. This becomes 33.87721219113. And this is not quite in scientific notation because in particular I need to move this decimal place one more to the left, so this would be a number equivalent to 3.387721219113 times a 10 to the first, because I would be wanting to make this number bigger because 3.3 is smaller than 33, times still that 10 to the third, and then I would condense my tens down to get 3.387721219113 times 10 to the fourth as my beautiful final answer. So in short, when you're doing the multiplication and division, you want to treat your coefficients separately than your tens. For your tens, you want to treat that with normal exponent rules on how multiplication and division by the same base works. And then at the end, you'll want to reconvert them back to scientific notation. If you notice yourself initially having to move that decimal to the left to make that coefficient in scientific notation, then you have to counterbalance that by multiplying by an additional 10 to a positive number, the number of ways you move the decimal place. And had I had to move that decimal to the right, I would have instead multiplied by 10 to a negative number to counterbalance that. And at no point should you be changing the value of the number. So it's always worth double checking on a calculator of some sort that you haven't changed the value of your problem.